Robert. I haven't even put it in yet. Someone else did. Someone else. Okay, we're going to continue working through our log test review. Was anyone not here yesterday? The review process. So we're still going to work through our original package. And if we have time, we can start the new additional review package, review problems that includes. Okay, so we worked through the odds. Let's work through the evens on page 26, and we'll pick up on page 27. So go ahead and work through the evens. I'll go through the answers with you. The key is attached in the new packet. So I have to be attached in the new packet. Hey guys, even. Okay, number two, there's a hidden base. That base is 10. 10 to the 4.5 equals X. Number four, there's the exponential form, log base E of 148 equals 5. You can leave it as log base E, or you can write it as natural log, LN. Be comfortable representing them in either form or recognizing them in either form.
Question during the testimony.
It'll just be front and back. It'll be like, I think the new test is different kind of a. Yeah, all these test reviews are longer than the actual test,
Okay.
so it'll just be front and back of one of each type. Yeah. Number 6 and 8. Get it into exponential form and then solve for X. Or see if you can get both sides to match with the same base so that you can figure out what the exponent value is.
How would you figure out number 8?
So 0.01 is the same thing as 1 over 100. And if I want to represent 1 over 100 in terms of 10, it's 1 over 10 squared, and it's really 10 to the negative 2. bases to match, you can just drop the bases and set text equal self-ref. So for number 12, I saw an opportunity for the base 2 and that root 32 to find a common ground there. So I know root 32, is 32 taking us 2 to the 5th power. And for roots, I can pull that out as 1/2. So 2 to the 5 over 2 or 2 to the 5 times 1/2 is 5/2. If I can get the base and value to match, I can drop those. I can bring that 5/2 down as a coefficient, and then 8 times 5/2 will give me a numeric value that I can reduce. Okay, 14, you're just expanding, trying to find a way to get the x, the y, and the z to all be separated by either plus or minus. Okay, 14, you see that we have the ability to pull that this root out as 1/5, pull that 1/5 down in front, and then just think of it as bring that 1/5 through my product property. I can separate the log x squared, log y cubed, log y to the 4th, log z to the 4th, and then as soon as I do that, I can also bring the exponents down individually. And the 2 can come down in front, the 3 can come down in front.
I'm still really confused about, why would you go straight to square root of 25?
Oh, sorry, not square root 25, square root of 2 to the 5th. Yeah, sorry, I didn't make that exponent look small enough. So I kind of skipped a step here. When I expanded, I shouldn't, you know, I showed the step, but, the x squared, the y cubed is equal to 4. Stay up as exponents initially, and then once they're separated, then they come down, in front, for each individual term. Okay, any questions with page 26? Yeah, page 26. Okay, let's go to page 27. Okay, let's work through the evens first, and then just so that we can see everything, and then if we have time, we'll come back and do the odds. But yeah, so let's go with the evens on page 27. So now we're condensing. So condensing is where we're putting everything back as one log term. So so now you're doing the other, yeah, so now you're going the opposite direction. So for number 16, what we can do is let's bring all the coefficients up as exponents. Be careful though that that 1/3 for that log base 47c, that 1/3 is going to see both the 7 and the c. So you know, either put 7 to 1/3 c to 1/3, or you put that instead of put the c as a reminder that the 1/3 is not just for the c, it's also for the 7. Okay, so that's the first step of condensing, bringing having the exponents in place. And now you just want everything as one log base 4 term. And you just have to find a home for that 8 to the 5th, b to the 6th, and the 7c to the 1/3. And then they're either going to go to numerator or denominator. And the way you quickly know is whether the log term is part of a positive term or a negative term. If there's a negative in front, then you want to put that term in the denominator. If there's a positive in front, it's part of a positive log term that goes in the numerator. So a to the 5th, b to the 6th, they both stay in the numerator. 7c to the 1/3, there's a negative in front, so that's going to drop down to the denominator. You can either leave it as 7c to the 1/3, or you can bring it back as cube root. Either way is fine. But we do need the a, b, and c in the right places. Okay, skip 17 for now, try 18. Bring the coefficients up as exponents first, and then you're just going to have one natural log term, and you're just going to find a place for the x, the y plus 8, the y, and the 10 minus x. Go with 18, go to number 20. Sorry, 18, sorry, the numbers are not lined up here. It goes back to 14 here, so, middle of the page, 14. So anytime I'm solving for exponent variable, I'm always thinking, well, there's always that option to take log of both sides, which is perfectly fine. But for 14, if I see an opportunity for me to get the bases to match, then that could potentially just be a little bit faster that way. Yeah.
I think for the top, could you do like x to the third parentheses y plus 8 there's nothing in the square root? Or is it like different?
Yes, you could do that. Yeah, they both are multiplied. You can have one square root and then x to the fifth y plus 8. Yeah, that's fine. Yeah.
Okay.
Yeah, if you want to write it this way. This is fine. You can write it this way if you want. So 14, I want to solve for x. X is an exponent. I could use logs, but the 125 and 25, it looks to have a nice relationship. What can I bring both down to as base what? Base 5, right? So if I can do that, I think that's a little faster. But number 16, we'll be stuck, right? Because we can't bring 12 in terms of 2 or 4. It's not a nice, it's not a nice common base that's shared. So with 16, you have to take log of both sides. But for 14, I think the faster way is get the bases to match. So 125 is 5 cubed. 25 is 5 squared. Once I get that set up, I can get the bases to remove. I can remove the bases and then focus on my exponent. Distribute the 3 through, distribute the 2 through, and then solve for x. If you're solving for an equation that's in the exponent form, there's no need to test your answer. Your answer can never, you don't have to worry about extraneous solutions. Okay, you only have to worry about extraneous solutions if you're starting with a log equation, and you go back and test to make sure that it's not causing an issue with a negative value inside the log. 16, we have no choice but to take the log of both sides. So we take natural log, we take log base 10. Both sides, I'm just going to use log base 10. But you can do natural log and you get the same answer. Okay, so
Would you get a negative exponent?
negative exponent is fine because it's not going to cause an issue. I can have a 125 raised to the negative 10. But if my equation starts off as log of x minus 8, then I got to go back and test it. So a problem like these problems, page 28, like these equations, then I got to test. Exponential equations, I'm fine. Okay, so 16, we got to take the log of both sides. So log of 4 to the x minus 1 equals log of 12. Once you are inside a log expression, your exponent is free to move. You can move that exponent x minus 1 down in front. Make sure you protect it with a set of parentheses. Then you can divide both sides by log 4, get that decimal value, and solve for it. Once I'm inside log expression, that x minus 1 comes down. Log 4, log 12, get those to divide out, get a decimal value out of it. Sorry, I didn't create a decimal value, but let's do it right now.
Why does the log 4 just move over?
I divided both sides by log 4. Log 12 over log 4 gives me a decimal value of 1.79. 1.79 plus 1 is equal.
Dividing, you just like,
Yeah, I just put it in the calculator, log 12 divided by log of 4. There's a log button, yep. There's a natural log button and a log button. So if you decide to take the natural log of both sides, it'll still work. You'll still get the same answer. Let's look at 18. 18, look at the setup here. Can you tell what type of a problem this is going to be? Factoring, yeah. So, but this one feels a little bit strange because the degree is a little high. So we can let y equal to e to the 2x, or y equals e to the x. Sorry, I'll work this through. Just a little bit longer here. Degrees are a little bit high, but we can still think of it as a factoring problem. Multiplies to be -6, adds it to be -5. Yes. So let me see here. Sorry, I got to multiply to be -6, so that's not going to quite work.
so we would do it like the other way, the other side thing,
Uh,
because I don't know how to do this one.
through this method. Yeah, let me see. Times c is -6.
Well, how does this stand?
Yeah, let me go through the star method. So the idea is that a times c is -6, right? And my middle value is -5. So I'm trying to figure out what two numbers multiplies to be -6. The same two numbers add up to -5. So -6 and 1. You can always double check it, right? -6 times 1 is -6. -6 plus 1 is -5. And then we have to worry about the coefficient here. 6 and 3 reduces to be 2. And I have x plus 1/3. Throw the 3 out in front. All right, I'm using y's here. And once you have it in factor form, bring back your e to the x. Yeah, I'll work on the I'll work this out tomorrow using the grouping method if you want to see that. So 6 divided by 3 is 2, and then 1/3 is a fraction. So I have to pull my coefficient, my denominator out in front. So anytime I have a fraction, that's the trick there, is that any leftover fraction, you're just going to pull it in front of the variable. Mhm. So you have to still involve that 3. Oh, my bad. I'm sorry, guys. This is e to the x. This is y to the 4th, and so both of these should be squared here. That makes it for a more complicated problem. Sorry about that. Yeah. So It's e to the 2x minus 2 and 3 e to the 2x plus 1 because I have y squared. It's a little more difficult than what you're going to see, but it's good to practice through this. I want to solve for x. X is stuck in the exponent. Take the natural log of both sides. I cannot take a natural log of a negative number, so that's out. No solution there. The only solution I get is natural log of 2 over 2. Okay, continuing with the even, page 28. So number 20, looks like I got the opportunity to, I want to solve for x. X is stuck in that log form. Here I can just jump directly into converting into exponential form. Reduce that x away from that log. So exponential form is base 8 to the second power equals the value. Solve for x, x equals 21. So this I got to check, right? So I've started off with a log equation. I got to plug 21 in, make sure it's okay. Doesn't conflict with any, does not cause any issues. So that 21 is safe. Okay, 22. We do want to solve for x. X is stuck in log form. We definitely do want to convert it into exponential form, but there's something that needs to happen first. What needs to happen first? I gotta get the two log terms to come together. What property can I use? Yeah, I can multiply, right? Product property here. So log of A plus log of B is equal to log of A plus B. I can push those together. Once it's in that cleaned up form, now I can go to my exponential form. Do x if you want. 4 to the second equals x times x plus 6. It's going to be a factoring problem. Expand everything out, bring everything over to one side, go through the factoring and solve for x. Just one back, you can send it to the other later. I already sent it. Okay, that's well. Okay, multiply to be negative 16, add it to be 6, 8 and negative 2, solve for x. I got x equals 2 and x equals negative 8. I'm going to test both of them in both of the log terms. The 2 is fine, doesn't cause any issues. The negative 8 causes an issue with, if it causes an issue with either of the log terms, we have to remove it as an extraneous. Okay, 24. So the 19/24, they're all showing log base 7, so that's a nice relationship on both sides, but you can't quite drop the log base 7 just yet. You gotta clean up that left side. How do we clean up the left side? Yeah, log of A minus log of B equals log of A over B, yeah. So once you get that one-to-one relationship, then you can drop the log base 7s from both sides. Then you can cross multiply, work your way to solve your program. It end up being a factoring problem. Still, once you cross multiply, you can see that squared in the way. So we're trying to figure out what two numbers multiply to be negative 12, add them to be 1, negative 4, and sorry, positive 4 and negative 3. Consider that they're both got to still involve that 2 there. 4 and 2 reduces, which is nice. 3 and 2 doesn't reduce. We can pull that 2 out in front. And solve for x. We have the safe. Doesn't cause any issues with any of the parentheses in my original equation, but negative 2 causes issues, so we have to remove that as an extraneous solution. Okay, can we do one one graphing problem so we can see everything? Let's do 26. Last one. Page 29, 26. List out the transformations. The parent graph is a log base 4 of x. transformations that we see is that +6 is doing something to the graph, the -2 is doing something to this graph. What's that +6 going to do? Shift the graph in which direction? Left, yeah, left 6 units and then down 2. Good. Right. And there's 3 things that we need to build our graph. Let's find the vertical asymptote. Let's find 2 order pairs, and that should give you plenty of enough information to sketch out your graph. I said x-intercept, but don't worry about it. So we know -6 is where the vertical asymptote is. Whatever causes the parentheses to be 1 is a nice property. So if we put a -5 in for that x, -5 plus 6 is 1, log of 1 is 0. That's nice. 0 minus 2 is -2. We can do all this without a calculator. And then the other property that I want to target is how can I get that base to show it within the parentheses? If I put a -2 in for x, -2 plus 6 is 4. Log base for 4 is 1. 1 minus 2 is -1. So I have my vertical asymptote and 2 order pairs. That's enough to get my graph. Be fairly accurate. Domain is from your asymptote to the right. Range is always all real numbers. In this case, I don't have to worry about the x-intercept. Tomorrow we'll work through the rest of worksheet 1, and we can also tackle the new handout that I gave you. Thursday, another review day, and then Friday, the test is just front and back. All right, come get your phone.